When we consider the acid-base reactions or neutralization reactions at this level, we can think about these reactions much in the same way as we think about precipitation reactions, in that ions will switch partners to form the products. This general type of reaction is known as double displacement, and in an acid-base reaction, the acid will always provide a proton, the base will always provide a hydroxide, and these two ions, proton and hydroxide, will always react to form a water molecule. In a typical neutralization reaction, the proton cation from the acid combines with the hydroxide anion from the base to form a molecule of water. And the anion from the acid and cation from the base will form the ionic compound or salt. So let's look at an example of this. Let's write the neutralization equation for the reaction of hydrochloric acid and sodium hydroxide. So the first step is to write out our formulas, and again, you are permitted to write the formula and name of the strong acids and strong bases and any other acids and bases you think might be necessary. So the formula for hydrochloric acid is capital H, capital C, lowercase l, and we'll put the phase in there of AQ. And the formula for sodium hydroxide is capital N, lowercase a, capital O, capital H, and again we'll include the phase of aqueous. When we separate hydrochloric acid into its ions, the proton is capital H with a positive 1 charge, and chloride is capital C, lowercase l, with a negative 1 charge. Sodium hydroxide, sodium, capital N, lowercase a, with a positive 1 charge, and hydroxide, capital O, capital H, with a negative 1 charge. We're going to switch cations and anions. So now the proton will be paired up with the hydroxide, which always, always, always forms a water molecule, and our salt will be formed from the sodium cation and the chloride anion. These charges are opposite, so the formula for sodium chloride is a 1-to-1 ratio of cation to anion. Our equation reads capital H, capital C, lowercase l, AQ, plus capital N, lowercase a, OH, AQ, arrow or forms capital H subscript 2, capital O, phase of liquid, plus capital N, lowercase a, capital C, lowercase l, phase of AQ. Any compound with sodium will be AQ, and you could use your solubility chart to test that, or to check it, rather.